The National Electrical Code, specifically Section 200.6, addresses colors for conductors and equipment. Other relevant publications include ANSI/NEMA WC3, which covers wire and cable for use in distribution systems at 600 volts or below, UL 1072, which covers flexible cords and cables, and UL 1426, which covers non-metallic sheet cable type NMB. Color codes are used for specific applications like alternating current or AC power systems, direct current or DC power systems, control circuits, and communication cables. For AC power systems, black typically indicates an unmarked phase, often referred to as lone. Red designates a marked phase, commonly L2. Blue also marks a phase, typically L3. White is used for the neutral conductor. Green or bare copper signifies grounding conductors. For DC power systems, black is used for the positive conductor. Red identifies the negative conductor. White or gray is used for the neutral conductor, if one is present. Green or bare copper denotes the grounding conductor. In control circuits, black is often used for line 1. Red is used for line 2. White represents the neutral or common conductor. Green or bare copper is used for grounding. For communication cables, brown is used for the positive conductor. Orange is used for the negative conductor. Yellow is used for the shield. Black denotes grounding. It's important to note that while the NEC specifies colors for ungrounded conductors, there isn't a specific requirement for the grounded conductors, allowing some flexibility. Color codes can vary based on the specific application and the manufacturer. It's always crucial to refer to the manufacturer's specifications or the applicable code requirements for the specific color coding used in a particular installation. The NEC provides the foundation for safe electrical practices, and understanding these color codes is essential for proper identification and maintenance of electrical systems. Knowing the color schemes allows for the correct wiring and troubleshooting. This leads to electrical safety for all personnel working with or around such electrical systems. While specific sections of the NEC define conductor colors, other sections relate to conductor installation, such as NEC 310.15, which covers ampacity of conductors. Also, NEC Article 400 covers flexible cords and cables. The color codes help to easily identify the conductors. Different systems use different voltages, so the color codes do not indicate the voltage, but rather the function of the conductor within the system. In AC power systems, you might have a 120/240 volt single-phase system or 208 volt or 480 volt three-phase system. The color code identifies the phase legs and the neutral regardless of the voltage level. In DC systems, common voltages are 12 volts, 24 volts, or 48 volts. And the color codes help identify positive and negative polarity. Control circuits often use 24 volts alternating current or direct current, or 120 volts alternating current. The color codes maintain consistency in identifying the conductors despite the voltage variations. The NEC also has requirements for marking conductors, allowing the use of tape or other means to identify conductors if needed, as long as the markings are durable and easily visible. In older installations, the color coding might not strictly adhere to the current NEC standards. Older wiring may require careful tracing and identification before working on the system. Always use appropriate testing equipment to verify the conductor's functions and polarities before any work begins. Grounding is a critical safety measure in electrical systems. It provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. The green or bare copper conductor is always dedicated to grounding. It should never be used for any other purpose. The neutral conductor is a current carrying conductor that provides a return path for unbalanced current in AC systems. The white or grey color is reserved for the neutral, and it should only be used for this purpose. The NEC allows for the re-identification of conductors under certain conditions, such as using tape to change the color of a conductor, but this is generally limited to specific situations and must be done according to the code requirement. Always consult the latest edition of the NEC for the most up-to-date information and requirements. Also be sure to refer to local amendments or regulations, as they may differ from the national code. Proper color coding and identification of conductors are essential for electrical safety and proper system operation. It helps prevent wiring errors, reduces the risk of electrical shock, and simplifies troubleshooting and maintenance. The color coding schemes discussed apply to North American standards. Other regions may have different color coding conventions. It's essential to be aware of the specific standards and regulations in the area where you are working. Wire and cable manufacturers typically follow industry standards for color coding, but there can be variations depending on the product and its intended application. Always refer to the manufacturer's specifications for the most accurate information. The color coding of conductors can also be important for documentation purposes. Accurate records of wiring and cable installations are essential for future maintenance and troubleshooting. Using consistent color coding practices helps maintain accurate documentation. When working with electrical systems, it's important to remember that electricity can be dangerous. Always follow safe work practices and use appropriate personal protective equipment. If you're not qualified to work on electrical systems, consult a licensed electrician. Understanding the color coding of conductors is a fundamental aspect of electrical knowledge. It's important for electricians, technicians, and anyone who works with electrical systems. By following the NEC and industry standards, we can ensure the safety and reliability of electrical installations. This helps to maintain and improve electrical safety. One must always prioritize safety and adhere to established standards and regulations. The use of proper color coding in electrical systems is more than just a matter of convenience, it's a fundamental aspect of electrical safety. By consistently following the prescribed color codes, electricians and technicians can quickly and accurately identify conductors, reducing the risk of wiring errors and potential hazards. This is particularly important in complex electrical installations where numerous wires and cables are present. The ability to quickly differentiate between phase conductors, neutral conductors, and grounding conductors can save time and prevent costly mistakes. Moreover, proper color coding facilitates troubleshooting and maintenance. When problems arise in an electrical system, the color codes provide a valuable roadmap for tracing circuits and identifying the source of the issue. This can significantly reduce downtime and minimize the disruption to operations. In addition to the safety benefits, proper color coding also promotes professionalism and consistency in electrical work. When all electricians and technicians adhere to the same color coding standards, it creates a common language that improves communication and collaboration. This is especially important on large construction projects where multiple contractors and subcontractors may be involved. Furthermore, the NEC color coding requirements are not arbitrary. They are based on years of experience and industry best practices. The colors have been carefully chosen to minimize confusion and ensure that conductors can be easily identified, even in dimly lit or visually challenging environments. For example, the use of green for grounding conductors is a universally recognized symbol of safety. Similarly, the use of white or gray for neutral conductors helps to distinguish them from phase conductors, which are typically black, red, or blue. In some cases, the NEC allows for the use of other colors for phase conductors, but these colors must be clearly identified and documented. This flexibility is important to accommodate the diverse range of electrical systems and applications. The NEC also recognizes that certain situations may require the use of different color coding schemes. For example, in control circuits, the color codes may vary depending on the specific function of the circuit. In these cases, it is essential to clearly label and document the wiring to avoid confusion. Furthermore, the NEC is not the only source of information on color coding. Other industry standards, such as those published by ANSI and NEMA, also provide guidance on conductor identification. These standards may offer more detailed information on specific applications or industries. In addition to the color coding of conductors, the NEC also addresses the identification of equipment. For example, the NEC requires that all electrical equipment be clearly marked with its voltage, current, and other relevant information. This helps to ensure that equipment is properly installed and maintained. The NEC also includes requirements for the grounding of equipment. Grounding is a critical safety measure that helps to prevent electrical shock hazards. The NEC specifies the types of grounding conductors that must be used and the methods for connecting them to equipment. Proper grounding is essential for protecting people and equipment from electrical faults. In addition to the NEC, there are also other codes and standards that may apply to electrical installations. These codes and standards may be adopted by state or local governments, and they may be more stringent than the NEC. It is important to be aware of all applicable codes and standards when designing and installing the electrical systems. In conclusion, the color coding of conductors is a critical aspect of electrical safety. By following the NEC and industry standards, electricians and technicians can ensure that electrical systems are properly installed, maintained, and operated. Proper color coding helps to prevent wiring errors, facilitates troubleshooting, and promotes professionalism in the electrical industry. The NEC also covers topics such as wiring methods, overcurrent protection, grounding and bonding equipment for general use, special occupancies, special equipment, and communication systems. These articles provide detailed requirements for the installation and operation of electrical systems in a variety of settings. The NEC is updated every 3 years to reflect the latest advances in technology and safety practices. It is important for electricians and technicians to stay up to date on the latest edition of the NEC to ensure that they are following the most current requirements. The NEC is a complex document, but it is essential for anyone who works with electrical systems. By understanding the NEC requirements, electricians and technicians can help to ensure the safety and reliability of electrical installations. Also, the NEC is not intended to be a design manual. It provides minimum requirements for electrical safety. Electrical engineers and designers must use their professional judgment and experience to design electrical systems that meet the specific needs of a project. They must also consider other factors, such as energy efficiency, cost, and reliability. The NEC is a valuable tool for electrical professionals, but it is not a substitute for knowledge, experience, and good judgment. It is important to use the NEC in conjunction with other resources and to consult with qualified professionals when necessary. The NEC also includes informative annexes that provide additional guidance and information on various topics. These annexes are not part of the enforceable requirements of the NEC, but they can be helpful in understanding the intent of the code. The annexes cover topics such as ampacity calculation, conductor properties, and wiring methods. Also, the NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. The NEC is developed by a committee of experts from various fields, including electrical engineering, contracting, manufacturing, and inspection. The committee meets regularly to review and revise the NEC. The public is also invited to participate in the NEC development process. This ensures that the NEC is a comprehensive and up-to-date resource for electrical safety. The NEC is a cornerstone of electrical safety in the United States. By following the NEC requirements, electricians and technicians can help to prevent electrical hazards and protect people and property from harm. The NEC is a valuable resource for anyone who works with electrical systems.